Recently, very important news were published about Space Force and a lot of news. The first news with us says, U.S. Space Force picks Rocket Lab for 2025 Victus Hayes Space Domain Awareness Mission. The continued push for space domain awareness comes with contracts between the U.S. Space Force and space services companies to create missions that will align with national security needs. Earlier this month, Rocket Lab announced a $32 million contract with Space Systems Command, an organization within the U.S. Space Force responsible for the service's development and acquisition of new space technologies and capabilities. The contract is to develop a spacecraft and command and control center for the Victus Hayes tactically responsive space mission that aims to quicken the pace of launches deemed important for national security in order to more rapidly respond to future urgent on-orbit needs. The goal of this demonstration mission would put to the test the ability of the military's capacity to quickly position satellites in space to respond to threats and investigate suspicious objects. Peter Beck, Rocket Lab founder and CEO, said in a statement, "It's an honor to be selected by the Space Systems Command to partner in delivering the Victus Hayes mission and demonstrate the kind of advanced tactically responsive capabilities critical to evolving national security needs." Victus Hayes builds on Rocket Lab's proven track record of delivering launch and spacecraft solutions that enable advanced missions on accelerated timelines. The ability to design, build, launch, and operate a spacecraft within one streamlined team is rare and will deliver unparalleled speed and value to the nation. Rocket Lab will design and build a rendezvous proximity operation-capable spacecraft which will be slated for launch in 2025. Once given the go-ahead, Rocket Lab will send its spacecraft into a target orbit where it will team up with a spacecraft being built by True Anomaly, which was also awarded a contract for $30 million. Together, the pair will undergo an exercise that will showcase a realistic threat response synopsis and serve as an example of on-orbit space domain awareness. Even Rogers, True Anomaly CEO, and co-founder, said in a release, "True Anomaly is proud to partner with Space Systems Command to demonstrate tactically responsive space capabilities in peacetime to ensure the U.S., its allies, and partners are prepared to respond in the event of a real or perceived on-orbit threat. The space domain is one of the most challenging environments in which to test and train, and we applaud the service and Congress for their dedication to the mission set, which is increasingly necessary for deterrence, space domain awareness, and dynamic space operations." The second news with us says, Earth got hammered by cosmic rays 41,000 years ago due to a weak magnetic field. Earth is under constant bombardment by high-energy charged particles called cosmic rays. We're normally shielded from this barrage by Earth's magnetic bubble, the magnetosphere. What happens when the shield weakens? Cosmic rays are primarily hydrogen nuclei blasted into space by powerful celestial events such as the supernova deaths of massive stars. These incredibly energetic particles are normally intercepted by the magnetosphere, which also protects us from harsh solar radiation from the sun. The magnetosphere is not a monolithic, unchanging entity, however. Not only does magnetic north wobble slightly away from geographic true north, but the entire magnetosphere occasionally flips. This results in the field's north pole becoming south and vice versa, with the intensity of the field waning in the process. In addition to this, there are other brief periods during which the two magnetic poles of the magnetosphere disappear to be replaced by a multitude of magnetic poles. During these periods, called magnetic field excursions, the strength of magnetic poles also weakens, implying that our planet is less well protected from cosmic rays at these times. The question is, do periods of low magnetosphere intensity also correlate with major upheavals in Earth's biosphere, the complete zone of our planet over which life exists, ranging from mountaintops to the deepest ocean trenches? Sanja Panofska, a scientist at GFZ Potsdam in Germany, said in a statement, "Understanding these extreme events is important for their occurrence in the future, space climate predictions, and assessing the effects on the environment and on the Earth system to determine the periods during which Earth has experienced a heavier than usual bombardment of cosmic rays. Scientists can measure the abundances of different isotopes. These are variants of an element that have different numbers of neutrons in their atomic nuclei. When cosmic rays strike particles in Earth's atmosphere, they create showers of isotopes called cosmogenic radionuclides that rain down to our planet's surface. These build up over time in sediments, which scientists can study after recovering them from the seabed and in ice cores drilled from regions like Antarctica and Greenland. One well-studied example of a magnetic field excursion is the Lachem's excursion, which occurred around 41,000 years ago. Panofska has been studying the relationship between the intensity of Earth's magnetosphere and the concentration of cosmogenic radionuclides such as beryllium-10 during this event. She found that the average production rate of beryllium-10 doubled compared to the rate at which this cosmogenic radionuclide is generated by cosmic ray bombardment today. This indicates a very low magnetosphere intensity during the Lashemp's excursion, leading to vastly more cosmic rays reaching Earth's atmosphere and creating showers of secondary particles. Panofska used these measurements to reconstruct Earth's magnetosphere, finding that it shrank during this event when its strength decreased. She is hoping this reconstruction will help her and fellow scientists get more information from cosmogenic radionuclide and cosmic ray bombardments. The next news with us says, Cosmic fountain is polluting intergalactic space with 50 million suns worth of material. Tremendous explosions in a galaxy close to the Milky Way are pouring material equivalent to around 50 million suns into its surroundings. Astronomers mapped this galactic pollution event in high resolution, obtaining important hints about how the space between galaxies becomes filled with chemical elements that eventually become the building blocks of new stars. The findings came about when the international team studied NGC 4383, a spiral galaxy in the Coma Berenices constellation, using the VLT telescope instrument called the Multi-Unit Spectroscopic Explorer. Located around 6 to 2 million light-years from Earth, NGC 4383 is part of the Virgo cluster and is undergoing a strange and turbulent evolution. This includes the galaxy spitting out an outflow of gas so great it stretches across 20,000 light-years of space. This gas jet, containing enormous amounts of hydrogen and heavier elements, is traveling at speeds as great as 671,000 miles per hour. For context, that is around 450 times as fast as the top speed of a F-16 jet fighter. Team leader and University of Western Australia researcher Adam Watts said in a statement, "Very little is known about the physics of outflows and their properties because outflows are very hard to detect. The ejected gas is quite rich in heavy elements, giving us a unique view of the complex process of mixing hydrogen and metals in the outflowing gas." Watts explained that in the outflow of gas from NGC 4383, he and the team detected oxygen, nitrogen, sulfur, and many other chemical elements. These outflows are, in short, vitally important to the evolution of the cosmos. The elements they blast into intergalactic space will become the building blocks of the next generation of stars, planets, moons, and possibly even the foundation of living things that will someday come to dwell on those worlds. The team thinks the tremendous outflow of gas from this relatively close galaxy is the result of powerful stellar explosions at the heart of NGC 4383. That's because this region is in the throes of an intense burst of star formation. The most massive stars created in this bout of starburst are losing mass over their lifetimes via powerful stellar winds. After millions of years, stars like these die in violent supernova explosions. Both stellar winds and supernova explosions drag out a galaxy's gas and dust, therefore depleting its gas reservoir. Because this reservoir provides the building blocks for new stars, that depletion has the effect of slowing and eventually stopping star formation in galaxies that experience this phenomenon. In VLT image of the galactic fountains of NGC 4383, this outflow of material can be seen as bright red filaments shooting from the main, central body of the galaxy. We hope that in the future, MOVE observations will reveal the importance of gas outflows in the local universe in exquisite detail. The next news with us says, officials say Boeing Starliner spacecraft will not fly private missions yet. Boeing says it may sign up private astronauts for future Starliner missions, but the focus is on NASA for now. The spacecraft's program manager, Mark Nappy, told reporters Thursday the company is very focused on flying the first Starliner mission for NASA with astronauts on board. That mission, crew flight tests, will see NASA astronauts Butch Wilmore and Suni Williams rocket to space aboard a United Launch Alliance Atlas V rocket no earlier than May 6. Nappy said it really is all of our attention at this point during a telephone press conference from the launch area at NASA's Kennedy Space Center near Orlando. After that, Boeing will make sure it has enough spacecraft manufactured for future NASA astronaut flights, which are expected to run to 6 or 7. Private flights are a possibility, but not the concern for now given they are building out NASA flights through the International Space Station's possible retirement in 2030. We've got plenty of time to think about what's after that. Boeing's decision stands in contrast to the other private company that sends astronauts up to the ISS, SpaceX. 3 years after the Space Shuttle's retirement in 2011, both SpaceX and Boeing received contracts from NASA to send commercial crew missions to the ISS. As of 2014, when the contracts were announced, Boeing's commercial crew contract for Starliner is valued at $4.2 billion compared to SpaceX's $2.6 billion. SpaceX sent its first test mission to the ISS in 2020 and has provided 11 more astronaut flights to the complex since. 8 half-year missions for NASA and 3 approximately 2-week missions for private astronaut company Axiom Space. Axiom is in fact just one private entity that uses SpaceX's Crew Dragon spacecraft. In 2021, for example, Shift billionaire and private pilot Jared Isaacman flew to Earth orbit with 3 civilians on a mission known as Inspiration. Isaacman next bought 3 more Crew Dragon missions for a 3-mission private series known as the Polaris program. The first of the trio, Polaris Dawn, may fly with Isaacman and 3 other people as soon as this year and feature the first commercial spacecraft. Aside from that, numerous technical problems with Starliner since 2019 forced Boeing to absorb $1.4 billion in unanticipated costs. Starliner's issues delayed CFT by 4 years. The spacecraft's first uncrewed flight to the ISS in 2019 failed to reach its destination. Dozens of fixes later, a second test flight without astronauts safely docked with the ISS in 2022. CFT was delayed further in 2023 after critical issues with the parachutes, along with flammable P-tape in the spacecraft, was discovered. Steve Stitch, program manager for NASA's Commercial Crew Program, told reporters during the same Thursday teleconference that he was impressed at Boeing's methodical fixes to the issues. Stitch said the entire NASA, Boeing, and United Launch Alliance team and all the contractors have done a tremendous job working through a myriad of problems getting the certification done and getting us to this point today. Wilmore and Williams, both former U.S. Navy test pilots, arrived yesterday at KSC to continue their quarantine in preparation for CFT's launch. They aim to do a thorough shakedown of the spacecraft and all systems, including considerable manual flying and testing emergency procedures such as powering up the solar panels to help certify Starliner for 6-month missions. If CFT's flight goes to plan, the first operational mission will fly in early 2025 at the earliest for a 6-month tenure. That crew includes NASA's Mike Fink, NASA's Scott Tingle, and the Canadian Space Agency's Joshua Kudrick. A Last News With Us says, watch 2 gorgeous supernova remnants evolve over 20 years. When we picture what's in deep space, we often think of static images, colorful composites of distant objects like nebulas and galaxies frozen in time. The reality is that everything is moving, and it's moving fast. But given the vast distances involved, it's hard for us to see that motion. NASA's Chandra X-ray Observatory, however, has been taking images for decades long enough to compile time lapses that show the movement of deep space objects. And the team has just released 2 such movies, one of the iconic Crab Nebula and one of Cassiopeia A. The Crab Nebula, located some 6,500 light-years away from Earth, formed after a supernova explosion occurred long ago. Astronomers originally witnessed the event in 1054 AD using Chandra images taken over 22 years. The time-lapse shows the ring-shaped shockwaves emanating from the superdense, rapidly rotating neutron star at the nebula's core, creating ripples through the surrounding environment. Because of this rotation, the neutron star is also considered a pulsar, and jets of matter shoot out from its poles. Casa is another supernova remnant. It's located about 11,000 light-years away. Its explosion was witnessed on Earth around 340 years ago. In the new Chandra time-lapse, its expanding outer region shows the initial blast wave making its way out into space. Multiple shock waves move in opposite directions while rippling through the remnant, which you can see in the video. For this time-lapse, 19 years of Chandra observations were strung together to capture the motion. While Chandra is scheduled to take new images of the Crab Nebula this year, the future of the observatory is bleak. Given NASA's proposed budget for upcoming years, Chandra faces an early demise, its operating budget shrinking tremendously in the near future. But the budget is simply a proposal for now, and perhaps the outcry over Chandra in the astronomical community will change the tides before it's set in stone. Thank you very much for watching. Goodbye.